So we have a diagram here with vertical angles, and we want to prove that two particular angles are congruent. So it doesn't matter which set we pick. If we picked 1 and 2 or 3 and 4, it doesn't matter. And because we don't actually have angle measures, when we prove one set, we prove all vertical angles are equal. Okay? So let me zoom in here a little bit. So let's reason through this. How can we figure out that angle 1 and angle 2 have the same measure if all we know is that the lines are straight? What's that? Nothing? Yeah, we've defined linear pairs, supplementary, all of those things. Good. 1 and 3 are a linear pair. Also, angles 2 and 3 are a linear pair. Well, how does that help? And I'm not going to make you remember all the postulates. You probably, if you were in geometry last year, you did it more rigorously than we're going to. So, what does it mean to be a linear pair? They have to add to 180 and they have to be adjacent. So we're going to use the add to 180 idea. So we know that the measure of angle 1 plus the measure of angle 3 equal 180 degrees. How does that help? Two and 4 are, but that's not what we're going to use. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. Oh. Well, that's what we needed to know. How does that show that 1 and 2 are the same? Well, one way to do it would be to subtract the measure of angle 3 on both of them. So the measure of angle 1 equals 180 minus the measure of angle 3. And on the second one, the measure of angle 2 equals 180 minus the measure of angle 3. Therefore, 1 and 2 are the same, right? They're both 180 minus 3. Okay, another way, which might be a little bit faster, would be to say, you could just simply say 1 and 2 are the same because when you add 3 to each of them, you get 180. That'd be good enough for me. Okay, so let's do this in a more exact form. Okay, so the measure of angle 1 plus the measure of angle 3 equals 180 degrees. How do we know that's true? You could say because that, whatever the name of the line is a straight line and they're adjacent. You could also say they're a linear pair. So my proof doesn't have to be the same as yours. As long as yours explains the necessary components, it doesn't matter how you write it. We also know that the measure of angle 2 plus the measure of angle 3 equals 180 for the same reason. Okay? And I'm going to go ahead and jump straight to the measure of angle 1 equals the measure of angle 2. And there are several ways to explain that. I'm just going to say both are added to the measure of angle 3 to equal 180 degrees. What's that? Last year, were they more ornery about it? Yeah? And technically, we haven't proven the statement that it asked for. Well, what is it asking for? It wants to know that the angles are congruent. What did we prove? We proved that the measures are equal. What's the difference? What's the difference between congruent and equal measure? Well, they mean the same thing. Well, I mean, right. So measure means you get a protractor and you measure that angle. Congruent means that you could take the one angle. Oh boy. If I can. Nope. Won't let me. Congruent just means that if I laid it on top of itself, it would match, which essentially is the same thing. But inside a proof, measures use equal signs because they're numbers. Congruent can actually exist without numbers. So congruent is that equal sign with a little squiggle on top, and that just means that they have the same opening, which basically means they're the same size. So if you wanted to be ornery about it, you could say that angle 1 is congruent to angle 2, and then state because if their measures are the same, then they're congruent. So congruent is kind of nice. We can know congruent without actually knowing the angle size. So, but I don't care. If you want to leave this off, it's fine with me. Okay? All right. See how good you guys are at this. Okay, for this page, we're going to assume that straight lines are straight. All we know is that angle 2 is a right angle. We want to prove that angle 1 is acute. How can we do that? What's that? Yeah, that's a good way to get a 0, because it is. Or as Robbie Baker likes to say, well, it's obvious. It looks acute. No, we can never trust a picture. Because an angle looks acute does not guarantee that it is acute. Well, and be more specific instead of saying the whole thing. So AFD is a straight line. Good. So this angle is 180. Good. So we subtract off this 90. Good. So Peyton is saying angle 1 plus angle 2 plus angle, well, and these are all measures, right? Angle CFD equal 180, right? And we know that the measure of angle 2 equals 90 degrees. And how did you, there are a couple ways to say it, but how did you say it from there? Okay, um, so angle 1, the measure of angle 1 is equal to 90 degrees minus the measure of angle CFD, right? Well, can CFD be 0? No, because it exists. It's an angle, and angles cannot be 0. So CFD has to exist. Could CFD be obtuse? No, why not? Right. So no matter which side you argue, technically they both have to be acute. So the only way for this to work is if 1 and CFD are both acute. Therefore, angle 1 is acute. That works. Another way that you could do this without using any degrees. You could say that these three angles are a linear triplet, therefore they're supplementary. This is 90 degrees, which means that 1 and CFD are complementary. And complementary angles are always acute, by definition, right? If you have complementary angles, they both have to be acute. Yeah, so for 2-column, we're going to say angle 1, measure of angle 1 plus the measure of angle 2 plus the measure of angle CFD equal 180. And I would call them a linear triplet. Or you can say they're supplementary because they all lie on the same line, however you want to say it. Yep, linear triplet. And the measure of angle 2 equals 90 degrees. How do we know that? That's a given. So the measure of angle 1 plus the measure of angle CFD equals 90 degrees, which means, or wait, how do we know that? I would just say subtract the right angle. And because this statement is true, what other statement is true? The measure of angle 1 is acute. And the reason is both angle 1 and angle CFD must be acute. We kind of got the hang of that? Okay. So you have 4 proofs I'd like you to work on. If you turn the page, there's one thing that's not listed that I think we should list. So AFD is a straight angle. And you're trying to prove that BFE is a straight angle. So given that AFD is straight and these 3 other facts, a right angle, a 15-degree angle, and a 105, can you prove that the green line is straight? And then once you prove that the green line is straight, you need to prove that these 2 angles are a linear pair. So once you know that the green line is straight, then you can prove that it's a linear pair, which is super easy to do. Supplementary and adjacent. All right, turn the page again. So on this back page, we're going to go ahead and assume that all lines are straight. Maybe you want to make a note of that. All lines are straight. So given 2 things, that angle 1 is acute and angle CFD is 20 degrees, you need to prove that this angle is obtuse. AFE. So you want to figure out, you want to prove that AFE is obtuse, and then the last question is kind of tricky. It says prove that CFB is obtuse. So the second proof asks, can you prove that this angle is obtuse? And the answer is no. So you're asked to prove something that's untrue. So what you actually need to do is prove that it's untrue. Because CFB could be obtuse, but it could also be acute, depending on the size of angle 1. So for the last proof, you're not proving that anything's true. You need to show that this is either acute or obtuse. Or actually, you could prove right or obtuse. So you're going to show that a particular proof can't be done. Okay? You have about 22 minutes. I'm here to help. Feel free to work together. Uh, it's usually a good idea to have me or somebody else check your proofs. So once you get one done and you want me to read over it, I'll read it and tell you if it's good enough or if you want to add some things or maybe take some things out. Because there will be more proofs to come. Okay? Good luck.